My name is Beth, and my family own Mungali Creek Dairy. I started working for the company 3 years ago, and I'm really passionate about sustainable packaging solutions and, as of just recently, recycling, because I've learned that that's probably the most sustainable solution for us moving forward. And tonight with us here, we've got William Ritchie. William is a big player in this space. William, can you please introduce yourself to everyone here?
Well, I think a big player is probably pushing it a fair way, but
big solutions from a small player.
Start small. Yeah, so my name's William. I'm a scientist by trade, and I've done a bit of R&D development work. And basically, I got asked a couple of curly questions in relation to plastic recycling, and a few experiments later and a few tests, we've got a prototype or two up and running, and looking to do something with it.
And so just to give everyone a bit of context, you're a molecular scientist, and your uncle is very, very passionate about recycling, and he dragged you into all this. So how did it all get started?
Well, I was doing a bit of freelance R&D work, and he asked a couple of curly questions, like I said before. So we decided to test some assumptions that we made and possible avenues of inquiry. We set it, so the question was, can you melt plastic in bulk in a simple single stage apparatus? Because most of the stuff used in the industry requires complex machinery all chained together, moving it from one apparatus to another, shredders, granulators, extruders, etc., which means there's a hell of a lot of processing before you get to a product. So how can we do that and eliminate nearly all of that? So that's that was the question, and we tried some things, and we had a partial success. So we changed a few things around and tried it again, and we had a success. So we managed to melt some milk bottle for about a minute, if that, successfully. And I've got the original sample somewhere. He's up in Silkwood, so he's in a prime growing area of Queensland, next to all the banana farms. And he's had 30 years in recycling, so he knows it well, and he's looking at taking in waste and trying to get it to export market, etc., etc. So he was the one who put the question to me. We targeted banana bunch covers because they are a fairly good waste stream in the sense that they are not mixed up with a whole lot of other things. They are decommissioned from the trees when they're finished, and they basically put one bag inside of another until they get this great big bag full of them, and they pile them up. So there's nothing too contaminated about them. They're just a reasonably good, consistent source of plastic. So why not?
And so for people who aren't in banana farming, what is a banana bag and what do you need it for?
So I guess this is where I use my props. I've got two here. These are what they look like. They're a great big bag made of film, and that goes around the banana bunch. And it helps them ripen, it protects them from damage from pests, or protects them from mold, all sorts of things. So that's the other one. It's got a silver lining, and it's also got this sort of woven petticoat or micro mesh petticoat inside it. So there's two different sorts, and yeah, that's what they do. So it's fairly integral to growing bananas, from my understanding. It helps with production. Simple as that.
And I think that kind of just highlights, like, for a lot of people, I grew up in a banana growing region, so I know that these banana farmers use agricultural plastic waste. And I guess when we think about plastic, we think about like the bottles that we use every day or the items that we use every day, but there are just so many other places that plastic is used in this problem. It does feel very overwhelming at times. So can you explain to us what your machine actually does?
Right, so those banana bunches in the top? Yep, stuff them in the top as you see them. So it can be a banana bunch cover. It can be some more props here. It can be a fertilizer bag. Looks like that. That's how it goes in, exactly like that. So that's mostly polypropylene, which is a different plastic. Same thing. String. So these things, if you're recycling them conventionally, are very hard to process. That gets tangled up around any moving part. They're just a nightmare. So they can do it, but because they're difficult, it adds cost and adds extra machinery. So what ours does, we bunch it up literally like that and stuff it in, and that's it. It's no moving parts, nothing to get tangled on, and it simply melts it down, and it comes out the bottom like a flowing goo, and we just put it for a little tiny pump into whatever we want. Oh, once it comes out, you can do anything with it. So you can pump it into molds, you can injection mold with it. It's suitable for any manufacturing pathway.
And then I think for a lot of people, there's a big, people know that hard plastic can be recycled, but there is such a big thing about soft plastics, which is why you see companies like Red Cycle and things like that. You can put both hard and soft plastic in this machine?
Yeah, we've done both. So we've done bits of polypipe. We've done. Here's a good example, right? So a hard plastic. We haven't done PET. We're avoiding PET. We will test it at some point, but it's just it behaves a bit differently. We've done mostly the polypropylene, polyethylenes, all those sorts of thermoplastics. So hard plastics, yeah, in any form we can stuff it in. It doesn't have to be scrunchable like that. That is an idea that we had of making an ingot. So our intake on our machine is square at the moment. We can make them round or square. And that's roughly how big the intake is. We can take that block that we made from string, put it straight back in the top of the machine and remelt it over and over and over, many times as you want.
So you basically have plastic that's infinitely recyclable.
Exactly. So anything you make with it, and that's where the circular economy comes in. If you can take your banana bunch covers off the farm and in that single step make a new product, and if it's we don't know yet, but potentially make a new bag, we don't know. It's something that it's a question I'd love to answer, but I can't at this stage. If we can do something like that, then you've got circular economy on your banana bunch covers. But there's a million different things that we use on a farm every day that can be made with plastic and have their own recycling solution already in place. So things from drain pipes to fence posts, anything you want.
What's some of the things that surprised you working in this space? And
I think the number one is how much plastic is out there. It's staggering. You have to see it to believe it. I think where we see the stuff going to curbside bin, that's most, like we discussed before, that's our understanding when we're naive. It's enormous. I've seen things that I mistook for in the background of a pile of waste that I thought was a row of cypress trees, but it wasn't. It was just more plastic piled up. It just happened to be the same colour to make a silhouette, same height, same length. It was just enormous. You're talking hundreds of tonnes, and there's thousands and thousands of tonnes coming out of just agriculture alone every year. So when you think about the recycling rates at around, well, these are probably outdated statistics now. I know agriculture was roughly 7% was recycled. It puts it into perspective how much is either getting committed to landfill, which is largely unrecoverable, or it's been disposed of illegally. And it's not, as I've said, as I said to you before, it's not the farmer's fault. If there's no solution available, they'll come up with their own. And look, what we're trying to do is offer a solution. And
so you feel like you have a solution to the recycling crisis. Why isn't it being adopted right now? And why can't we use it everywhere?
Well, we're prototype stage. So the big wall in front of us is how do we get this thing big? I mean, we did this out of, we don't have a deep pocket. We don't have a company. We built the company around what we invented. And we did that on a shoestring budget, and we did it through sweat. It wasn't something that we could quit our day job and just move down an avenue of inquiry and see what happened, or we had a company backing us. We worked at night and we did what we did over the best part of a year, trying to solve a problem, and we're confident enough to take out a patent that we've done it. So that's where we're at. So now the wall in front of us is a bit of investment, and we get a big one built that will do hopefully a couple of 100 kilos an hour. Which
is quite a lot.
Well, that's one machine. So, and that's one machine that would fit in an area smaller than your bathroom. So when you consider how big a normal recycling plant is, some of them are 80 odd metres long. They cost well over $1 million to build all that infrastructure into them, all the processing and handling machinery before you even get to the product end. So there's an enormous amount of cost cutting if we do it this way. And one of the reasons we went and got stuff tested properly, that's banana bunch cover, that's a result of an independent test, is we were continually told, oh no, the plastic won't be good enough, it'll be too contaminated, that methodology and approach wouldn't work. Well, it seems to.
And that seems to be one of the biggest issues within the recycling industry is the contamination of plastic. That's why they stopped sending it. That's why China stopped accepting it, right? That was the sword policy.
That's a bit of a different scenario. So when they'd open up a container, it was just mixed waste. No one knew what was in it. There'd be dirty nappies. There'd be all sorts of filthy stuff in there. So I don't blame them for turning it back. But if you can get it and aggregate it straight off the farm through some sort of recovery system, and we trialled a few things there in Silkwood, they'd bring it in for nothing, just to get rid of it. So we couldn't take any more. It happened that quick with our trial. So, until we get a processing solution that we can start making things, then we'll take it in.
Isn't that what happens everywhere? Like, I don't know how many people know, but like with the lids from the bottles, and they were making a lot of prosthetic arms, and then they were getting absolutely inundated with bottles because everyone wants a solution for this, and you've got a solution here. It's so exciting. Rachel Watson said, how much plastic can you melt down at one time, which was a couple of 100,000 kilos, wasn't it? And is there a market for your plastic once it's melted down and extruded? How do you sell this stuff? Isn't this the big issue that we're trying to highlight here?
That's one of the things that you got to establish is market. So it was a couple of 100 kilos. That's what we want to make. Our current machine runs on about half of what your tea kettle runs on. So it's a complete proof of concept. It's temperature controlled. All the bells and whistles are ironed out. How we're going to do it is ironed out. We have engineering proposals ready to go and action. It's just a question of connecting dollars. The next large prototype, 200 kilos an hour. In terms of market, what do you do with that stuff after you've melted it down and made that and pumping that goo around? Well, you can make a granulate. So you just chop it up into bead. And that's what this was. This was a test sample of some of that granulate that we sent away to be tested and say, is this marketable? Would people buy this polymer as it's coming to you right now? Straight from our machine.
But isn't that what's happening in the industry? Like we wanted to package our products in recycled plastic, but it just seems like there wasn't any out there. And so the question is, how, when you have 84% of plastic not being recycled, yet you have the demand for the product, like how do we in this position? And you were saying to me before, it's really hard to enter this space for startups, isn't it? Like it's quite a volatile market, and there's not much.
It's sensitive because of the cost structure of recycled. It's almost dollar for dollar with virgin plastic. So if the oil and gas price dips, there's just no money in it. So Virgin can win. I think at the start of the COVID stuff, when the oil and gas price collapsed, it was cheaper to go and make something out of virgin plastic than it was recycled. That's just the price point on the market. So until you can come up with a methodology that can get that plastic ready for manufacturing again as a recyclate, and the cost structure and the cost is much cheaper than virgin, you're pushing it uphill. It's just not going to work. So that's one of the key questions and why we did this. You have to say, well, if we can take that waste and we can turn it into something that's usable again, a recyclate, even if it's just a little bead that you can make whatever you like out of, and that bead is suitable for what you're trying to make. They're the key things you need to be able to do. And if it costs a hell of a lot less than virgin at that end point, why would you buy virgin? It's as simple as that. At the moment, at
the moment it's going the opposite way. And why would you buy recycled when you can get the pure stuff cheaper?
Yeah, and virgin's reliable. Yeah.
And so you think it's making a cheaper product, or what else could we do to create a recycling industry in Queensland? And can it be created in far north Queensland? Emma asks.
Be created anyway. I think one of my pipe dreams on the back of this would be to how do you set up using the organic waste from the same industries that you're taking the plastic from, how do you use that to generate the electricity to run your recycling plant? That's a great question in itself. I think, Queensland's great. If you're talking agricultural plastic, which is an enormous amount of, you've got highly concentrated, high production agriculture in far north Queensland. They produce a hell of a lot of fruit and vegetables. They produce a hell of a lot of plastic. Now, there's no reason why it couldn't sit there. Go take the plant to the source. If you need an 83 to 100 or 86 metre long recycling plant to do that, you need a big shed. You got massive power bills, all of this sort of stuff. If you do it That's what we're trying to eliminate here. So that's why we did what we did. That's why we built what we built. We can reduce that right down, change the pricing, change the floor footprint, change everything about it, and do it a different way. It doesn't. Our machine, we're not interested in making stuff from virgin polymer. It's purely designed to recycle waste in its post-consumer state. That's it. So yeah, of course, Far North Queensland, perfect.
And then Anna's asked, are there any contaminants that escape into the environment? Like, are fumes released when it's melted? How does it all work there?
Best way of thinking about thermoplastics, which is like your milk bottles, your HDPE, polypropylene, low-density polyethylene, which is your banana bunch cover. It's like melting a candle. You can melt the candle and you can reform it. That's what your thermoplastics are like. So you shouldn't have too much stuff disappearing into nothing or being burnt off. It's really a lot like melting a candle. You might get a little tiny bit of smoke or whatever, but you can put, for example, if it was a problem, you can put it through an afterburner, in which case you've got clean combustion and you've got a minuscule amount of carbon going out into the atmosphere, but it's very clean. So there's ways around it, but if you're doing thermopolymer, shouldn't be an issue.
I think I said at the beginning, I thought recycling ended at the yellow top bin, you know. And so I think there's education that needs to happen across the board.
I thought if you put it in your yellow top bin, that was it. But a lot of that, because it's unsorted, it needs to be sorted. If there's a yogurt container still half full of yogurt, well, the yogurt to plastic ratio isn't good for recycling. You know, it's as simple as that. If it's like the banana bunch covers, all I have on them is a tiny bit of mold or film. Now, if it was dirt or an inorganic like that, it wouldn't matter. It would still go through our machine, no problem. And we can screen that out before you get to your product while it's a liquid. So while it's a hot liquid, you can put it through a screen and you take out any of that dirt. So contamination, you've got to be a little bit conscious of it. I've put my kitchen waste through. Obviously, I didn't leave pasta in a pasta bag. I took it out. That makes a difference because you're trying to recover the plastic, not the pasta. So you got to be a little bit conscious of it, and that's one of the keys here. So again, why did we target banana bunch covers? There's a hell of a lot of it. It's nice and clean. You know, it's decommissioned a standardized way. All we got to do is recover it and reuse it.
Now, I have one more question, and if anyone else has any questions, feel free to ask them. So does like make like then? Because like when you were showing us the blue twine before, it makes a blue polymer at the end. Yep. So how does that work with, because you see a lot of dyes in packaging today, and how would that work with like different, I don't know, your shampoo bottles that are a solid color and things like that? If you mix them all together, would you be just getting black? Like, can you make it clear again, or is it stuck in that color?
It's kind of stuck there, but it's a bit like painting. If you've got a nice blue one, that's the colour you're going to get from banana bunch cover of a set sort. If you use those silver lined ones, that's what you're going to get, a nice grey.
Yeah.
That's a blue black fertiliser bag. You can see the nice navy sort of blue to it. The blue string, that's the blue string that you saw before. That's what it comes out like. That's polypropylene. That's a little head wall prototype that we made at the end of the pump, just to see if we could mould a three-dimensional, you know, like you'd see on the end of your drainage pipe, just a miniature version. So that was string. So the colour comes through. But if you separate, for example, if you're only doing white bags like that, that's sort of going to be your natural colour. So in some cases, the string that I showed you before, this is relatively translucent. So you could add additional colours for it. You're not really going to get the blue out, but it depends what you're trying to make. If it's something that doesn't matter, if you're going to create a culvert drain and bury it, who cares what colour it is? Do you care if the fence post is grey versus black versus brown? I wouldn't. So there's plenty of stuff that you can do. You know, the one that gives you UV resistance is black. They put carbon black in it as an additive. It goes black, and that's it. You know, leave it black. Yeah, UV resistant. So it really depends. We're not aiming at food packaging here. We're aiming at the thousands of tons that have no home. So that's key.
And so, is there any way that we can all support you?
Yeah, look, any support's
support
good
businesses like yours. that are doing the right thing here?
We're out for investment. So, I mean, until we get that big machine built, we're sort of treading water, I suppose. We've done everything we can do with the prototype. You know, we've pivoted from throwing all the different types of waste we could at it to try and break it, and we didn't. We've now pivoted towards testing individual waste streams. So we've got a fair bit of data that we can present as part of our business case, and you know, with assumptions in the economics as always. But we have a fully costed, large-scale prototype just sitting there on paper, ready to go. We've liaised with engineering firms to get quotes and do all these sorts of things. It's just parked until we get the finance to support it.
And then one of the universities is supporting this, isn't it?
We've been through an accelerator program at my university where I went, which was La Trobe in Melbourne. They were terrific, but universities are pretty hard up at the moment. So that's the other bit that's tough is government grants. You've got dollar for dollar factor. So we'd have to cut, if we wanted $200,000 to build it, we got to come up with $100,000. There's no way around it. And then the prerequisites to make you eligible, you have to be a business that has a turnover of $1.5 million a year and all these other things there. So it doesn't point towards grassroots innovation at all. It points to, and we're not making a new type of drinking straw here where 10 grand gets you into the market. We're talking about a large piece of kit, of industrial kit. So you can't do any more than we've done on the budget.
Yeah, and then Brett Tate's just joined us at the last minute, and he was asking banana bags, back to banana bags. That's an option. It is, Brett. We were talking about that at the beginning, and that is exactly what you've designed, a circular economy there, right?
Well, that would be a good example. I don't know if it's possible. I mean, blow molding is fairly finicky, as I understand it. I'm no expert on that side of things at all. But looking at this, I mean, that's pretty thin. It's pretty consistent. That's injection molding, which is totally different. It would be a hell of an experiment to try. It really would. Yeah.
Well, I really hope you get to do it one day in the very near future. This is really exciting. It's like, I think everyone's feels stuck on the problem. So it's really nice to hear that there are people out there who have practical solutions that can be implemented.
Well, we've thrown everything we can at it, you know, and this was a lot. I don't know how we fell down this rabbit hole, but I think it was just a question that was too juicy to not have a go at, and somehow we had a partial result and kept following it. So yeah, it's the scary end now where we've got to make things happen. But yeah, look, it's interesting. The products that you could make from banana bunch cover, it's as good as your imagination. Now, fertilizer bags, there's thousands of tons of that every year. It's polypropylene, it's nice and tough, it's hard, it's rigid. Yeah, that would make an animal feed trough, no problem at all. You know, that's what they're made out of anyway, LDPE. Polypropylene, you can make a blend. Look at how many hardwood pallets are out there. They're everywhere, thousands and thousands
of them. Yeah.
Multi-million-dollar industry. Make them out of a recycled plastic.
Take them and melt them down.
If your pallet breaks, send it back in and we'll make you another one, you know? That simple.
Yeah.
So there's a million things you can make, but there's no point having it if your pallet costs twice as much as the wooden one to buy. No one will buy it. You've got to get it down.
You need to create that.
That's what we're trying to do. That's you take out all of that machinery, all of those overheads, all of those operational costs, and do it a really simple methodology to get your polymer. Can't see why we couldn't.
Yeah. Well, I wish you all the best for that. And let us know if you start a GoFundMe page. I'm sure there are lots of people out there who'd be keen to support that. I wish you all the best with it. Thank you so much for coming on and having a chat with us.
If people think they can assist, we're more than happy to talk to them. So GoFundMe and that sort of stuff down the line, you know, it's an option in getting investment money and getting yourself off the ground. We're looking at a couple of other avenues at the moment, but it's certainly on our radar. So we'll let you know for sure. But again, if anyone wants to thinks they know someone who can help or just get us off the ground, we got plenty of stuff we can show you.
All right. Well, thank you so much, Will.
Pleasure. Thank you very much.
You enjoy the rest of your night. Thank you.
You too.